Example 4 represents a more difficult function version of this absolute value function, where we have an absolute value on the inside. We also have it on the outside. The outside is not too hard to deal with, but the inside is going to be difficult to deal with. So I'm just going to first of all transform the outside. So my change in y is going to be, I'm going to subtract 4 first, and then do the absolute value. So when I do that, I can apply that to these coordinates. So that's going to be 5, 0, negative 3 becomes positive 3. That becomes negative 4, so positive 4. Negative 3 becomes positive 3. That becomes 0, and that becomes 5. So again, I just make sure that I keep track of that one point here, because that is going to be my mirror point. Okay, that's where I'm going to mirror. So I'm going to now show that when I do the x part of this. Actually, maybe we should just have a good idea what this graph looks like first. It's going to be just a regular parabola like this. So there's our regular parabola. So the vertical transformations are going to be, we're going to shift it down and then fold it up. So it's going to be shifted down, folded up. So it's going to look something like this. It's going to be down and folded up like that. Okay, so that's the vertical transformations. When we do the horizontal transformations, we have to be careful, because now we have absolute value, and we have to figure out what happens first. So this is my notation. My notation is backwards. So when I calculate this, I need to do the plus minus first, and then I'm going to do plus 2 as my transformation. So the first thing I'm going to do is a plus minus. So what does a plus minus indicate? A plus minus is undoing of the absolute value, which means we're going to get rid of all the negative terms, and we're going to mirror the positive terms. So what ends up happening here is all these negative terms disappear. Okay, they no longer exist, because we can no longer put a negative input into that x. Okay, all these x's that came out negative, it's impossible now, because when it comes out of the absolute value, all we're going to get is positive values that go into our original function here. So all these negative inputs no longer exist. And then what we do from that point is, then we're going to reflect. Okay, so that's going to be 0, 1, 2. We're going to get rid of negative and mirror, sorry, not reflect, but mirror. So I'm going to mirror those coordinates onto the other side. Okay, so I've mirrored the coordinates onto the other side, and then I'm going to apply. So that's my absolute value. So that's my plus minus being applied from here to here, and then from here to here is going to be my plus 2. So my plus 2 works out to be 4, 3, oops, I should move that over, 4, 3, the 0 point is going to be that point of reflection that I needed to keep track of. That's my point of reflection, now becomes 2, and then it becomes plus 2, so 1 and 0. So those are my new x coordinates. The y coordinates have to follow that, 0 and 5, and they get mirrored. So 2, 3 represents my mirror point, so 2 over 3 up, that represents my mirror point. I have the coordinates then, negative 1, 0 is here, negative 2, 5 is going to be here, 1, 0, or sorry, 3, 0, and, oops, sorry, I made a mistake here. I'm looking at the wrong table. This is going to be 0, 5, 1, 0, 3, 0, and 4, 5. Okay, so this is now my graph. It's going to be this section here, It's going to look like that.